Hello. So tonight, or today, I guess it is for you, we're going to talk about measurement. Now, as we go through this measurement slideshow today, I'm going to ask you some questions. And what I really want you to do is think about the answers and not just like, oh, that's that, or just kind of sit passively by. I really want you to engage in what we're talking about and think through it, because it's going to be, measurement shows up again and again and again, and it doesn't go away, and you'll use it for your whole life. And that's why we start with this question. What tools do you use to make measurements at home? Because some of you are very active in your home and doing different things, so think about it. What things do you measure, or what things do you use tools for at your house? So when I think about it, like at my house, I like to bake and cook, so I use measuring tools for that. I use measuring cups and measuring spoons, and I use, those would be things, teaspoons. Then I also use, I like to sew, so I have different ways to cut fabric, so measure fabric and cut it. I help my husband. He has a handyman job, and I help measure boards and cut them for that to keep track of the amount of paint we need. So I need to measure volume for that. So there's a lot of ways that we use measurement in our daily lives. And the interesting part about that is that it really transfers to the classroom. They do the same thing. So for example, at school, we might use a metric ruler or a meter stick to measure things measure the length of things. At home, you might use a tape measure or a ruler or a yardstick to measure things in inches and yards. So it's very different when you're measuring in inches versus centimeters, but that's what we are used to. The one that's the yellow one here, this is one you would use if you were sewing. So you can measure the length of someone's arm or the inseam or how deep a seam needs to be on something. Okay, so that's length. If you were measuring mass, you use a balance, and at home you measure weight, which is a little different. It's not exactly the same, but you might use a kitchen scale, or you might use a bathroom scale to keep measurements. Sometimes people have ways to measure things at home that are different or get the mass. Okay. If you were measuring for volume at school with science, we use beakers and graduated cylinders, which measure in liters and milliliters. So if you think liters is like 2 liters of pop. At home, you might use a measuring cup, which measures in cups and ounces to measure for a recipe or for something that you are doing at home. Okay. And lastly, temperature. We use thermometers all the time at school to measure the temperature of water or the air or the temperature underneath a light for a plant experiment. At home, probably the most common uses we have for thermometers is you might have one outside your house to see how warm it is, or you might use a thermometer to measure your temperature if you're sick. I know I had to buy one for my daughter to go back to college so she could take her temperature. So today we're going to spend time looking at different metric measurements and reviewing how to do them. I know you covered this in 6th grade, so this is just a review. So again, in science, we use beakers and graduated cylinders to measure volume. We use balances to measure mass, thermometers to measure temperature in degrees Celsius, and then we use metric rulers to measure length, and again, in science, we use centimeters. Okay. So the metric system, with a metric ruler, you use it for measuring distance or length, and you can measure in meters or centimeters and millimeters. And I like how this is laid out here. So for example, the width of a penny is about a millimeter. There are 10 millimeters in a centimeter, and a centimeter is about the width of your finger. And then there are 100 centimeters in a meter, and if you were at school, a meter is about the height of a doorknob at school, a little bit more. Okay, so measuring with rulers is for length or distance. So today I'm going to ask you, if you're watching this video, to go back, because I don't think that these are going to play very well. I'm going to ask you to go back. So this video, you're going to need to go to the slideshow and stop the video now and then go and watch this video on slide 10. And when you're done, come back to this slide 10 and move on. It's just a review of how to use a metric ruler. So if we were to practice here, I want you to look at the crayon and think, okay, how many centimeters, and you're going to use decimal points to be exact. So how many centimeters long is the purple crayon? And then how many centimeters being exact, so you'll use a decimal point because you're going to tell me how many centimeters, and then you'll include the millimeters by adding a decimal point. And then I also want you to think about the pencil and how many centimeters and parts of a centimeter is the pencil. Okay. I'm thinking for a second. Oops. So here we go. The purple pencil is 7.1, so it is one little dash, which is a millimeter, past the 7, so that makes it 7.1 centimeters. Or if we were to make that into millimeters, it would be 71 millimeters, because there's 10 millimeters in each centimeter. The screw is 5.1 centimeters, or 51 millimeters, because there are 10, so you'd go, if you're counting, you go 10, 20, 30, 40, 50.1, so 51 millimeters or 5.1 centimeters. And then the pencil here is, oh, that should be 2.6, not 5, 2.6. I must have missed, I can change it right now, 2.6 centimeters, because it's, if you go right here, you can count them all, or the longer one is always halfway through, or the 0.5. So if it was exactly at this longer one, it would be 0.5, but since it's a little past, it's one past it, that's 2.6. So 0.5, 0.6. Okay. The next one is to measure mass. And we measure mass in grams and kilograms. Now, normally when you guys think of weight, you think of pounds, and that's different. So balance does not measure weight, it measures mass, and mass is the amount of matter in something. So, for example, your weight on Earth would be different than your weight on the moon. However, your mass on Earth would be the same as your mass on the moon because you have the same amount of matter inside of you. So we measure in grams, and a gram is about the mass of a large paper clip. I don't really think about plastic centimeter cubes, but I think you use those in math, so maybe that's why we included it. So about a large paper clip is 1 gram. 1 kilogram is about the same as 2 pounds of hamburger, a little bit more. Or if you think about how heavy the bigger of the water bottles is, a liter one, that's about a kilogram. Okay, so again, I'm going to ask you, this is slide 14, so I'm going to ask you to leave this video if you're watching this and go to the slideshow and watch this video on slide 14 about how to figure out the balance, how to use a balance, and then come back to slide 14 and continue. So I'll give you a little second to do that. All right, so we're going to practice. So one of the things that's hard about balances is that you have to add up the different cars, and you have to maintain the place value. And so if you're not good at place value, if math isn't your skill, you might want to use a calculator to put them in, because that will take care of the place value for you and you don't have to worry about it. But what you do is you take the cars, so you take the biggest car first and you go, okay, there's 100. And then the second car is 60. So you say 100 plus 60. And then this last one, you have to look at two parts, what number it is, the big number, and then the small number, the dashes. So this is kind of like reading a metric ruler, that if I was reading this as a ruler, it would be 3.8. So I'm going to say 100 plus 60 plus 3.8. So I would add all those up to give me that answer. So I would tell you that this one is 163.8 would be the mass. So I want you to look at the other two and see if you can figure out the mass for those. I'm going to give you just a minute to do that. Okay, so if we go on, I did the math below so you can see what I mean about lining out the place values. I guess it was 163.7 if you can see it better. But this one over here, you would take the 100 plus the 90. And then here's the interesting thing. This is 0, so it would just be the 0.4. So 100 plus 90 plus 0.4 gives you 190.4 grams. The most common mistake on that one would be to say 194, but 194 would be over here. This would have to line up with the 4 right there. Okay, so this next one, I'm going to take 100, and then this is a 0. There's no tens, so I have to put a 0 in the tens column. Okay, and look at this 0.5, 5.6, so it would be 105.6 grams is the mass that would be found on that one. Okay, next is measuring mass or measuring volume using a graduated cylinder. This is a lot like using a measuring cup. So you always want to make sure that you get even with the base of it, and you want to get even with the bottom. Water sticks to itself, and it sticks to the edges of whatever you're measuring it in. So you always have to read across the bottom of what's called the meniscus. So if you ever see watch cooking shows, they'll get down and look at the volume to be exact. They'll look at their measuring cup to make sure that they're exactly there. What they're looking at is this meniscus, or the bottom of it, to see what their volume is, if it's actually perfect. Now, we think about ounces of things. So if you look at these different Pepsi containers, this one would be 2 liters. So a 2 liter of Pepsi, about a 1 liter. And then this one is 710 milliliters. And I'm not sure about these. I don't know what a Pepsi can is. But these are different measurements in milliliters. So milliliters are what we measure in most of the time in science. So again, this is slide 18. So I'm going to ask you to go to slide 18 in the slideshow and watch this video on how to read a graduated cylinder, and then come back and finish the slideshow. So I know this is a lot to ask, but I've also found that the videos don't play well and you guys don't like them coming through the Screencastify. So if we look at the graduated cylinders here, again, we have to read the bottom of the meniscus. So we want to make sure that we're reading straight across here. So if we take this one and we count up, we need to look for the fact that it might, if it's going up by 1s or 2s. So I look here and I've got 40 here and 50 here, and in between there's a longer line which indicates the middle. So if I go up, I'm going to go 40, 41, 42, 43. And so I would say that the bottom of this one is 43. Now you sometimes should check and go, if I keep counting, if I keep counting by 1s, do I get to 50? So 43, 44, 45, 46, 47, 48, 49. Yep, that works. 1s is correct. So I want you to look at the other two and come up with an answer that you think is the right answer for each of those graduated cylinders. So if you look at this next slide, this one we said was 43, it's at the base, and this one is 24. So you go 20, 21, 22, 23, 24, 25, 26, 27, 28, 20. Yep, that's right. And some of you are faster and you can go, okay, this is the 5, and but sometimes it's best to just count. This one is a little more confusing because they didn't put in the 5, so then you have to wonder, is it going up by 1s or 2s? But you can kind of start counting and realize, okay, 1, 2, 3, 4, oh, okay, they're going up by 1s, so this would be 32 milliliters. So those are good examples. We also, when we're calculating volume, have to be able to calculate the volume of a box, or what's called a regularly shaped object. And to do that, excuse me, you just need a formula, and you need to know the length and the width and the height of the box, and you do that by using a ruler to measure that distance, or the length. So if I take my ruler right here and I line it up, we can see that this length of this cleanest box is 6 centimeters long, and then I took the ruler and I measured this, and it was 3, and this was 4. So my length was 4 centimeters, my width was 3 centimeters, and my height was 6 centimeters. So if volume is length times width times height, I'm going to take my length, which was 4, times my width, which was 3, and my height, which was 6, multiply those together, and I get 72. The common mistake here is we add instead of subtract. or add instead of multiply, excuse me. Make sure that you remember that you are multiplying those numbers together, because you want to find the volume of the whole thing, not just the edges. Okay? So you're width, length times width times height, and that is how you calculate that. So you can use a calculator if you have one, or you can do the math in your head if you're good at that. The only one that might be really challenging is the pink box. But so you're going to take the length, which is, let's say, is 4, times the width, which is 7, times the height. So length times width times height. So 3 times 4 is 12. 12 times 7 would be our answer, and we'll get that in a second. And then we've got, this one's easy. We've got 4 times 5 times 10. So 4 times 5 is 20. 20 times 10 is 200. And then here you would take 16 times 9 times 4. So here our answers, again, are 84, 200, and 576 centimeters cubed. And I should put those answers in the boxes, and I will do that later. But those are your answers for those. The last thing is reading thermometers, and here the most common mistake that people make is they don't read the centigrade side or the Celsius side. They read the Fahrenheit side, and we are very used to reading the Celsius or the Fahrenheit side because that's what we're used to. So when you think about it, when measuring science, we always use the Celsius. So make sure you pick the degrees C or degrees Celsius. And then step 2 here says, remember to pay attention to the scale. Sometimes thermometers go up by 1, and sometimes they go up by 2. And occasionally they go up by 5, so you need to make sure you're paying attention to that. Now, one of the other things you can always check is sometimes people get a little distracted and they go, oh, 42. But if you look at that, because they count this way, but if you look at this, where the red ends, the number has to be between 30 and 40. So one of the mistakes we have to make sure is, does my answer make sense? So is my answer between the 30 and the 40? If you said 42, that doesn't make sense because 42 would be up here. So check to make sure that your answer makes sense. And then for this one, the answer would be 38 degrees Celsius. So I'm going to show you some examples. So for example, at Celsius, water freezes at 0 degrees Celsius. In Celsius, our human body temperature is 36 degrees, which is kind of surprising. And then water boils at 100 degrees Celsius. So when reading the temperature of a liquid-filled thermometer, also it's kind of like reading a graduated cylinder. You need to make sure that you get even with it so that you're looking right at the line where it goes to. So I want you to look at these and practice reading these. Again, be careful of the scale. Look at the 3 thermometers and think, what do I think the temperature is on each of those? So the answer for the first one is 28, and a lot of people said 29, and in that case, you are not right because this one goes up by 2s. If you notice, it goes 20, 22, 24, 26, 28, 30, because you have to read the Celsius side. Also, what I see sometimes is people giving me 80, I think it would be 84, because they read the Fahrenheit side. So if you said 84, you read the wrong side of the thermometer. Okay. Now this one where the mistake is that we forget the negative sign or we count the wrong direction. So that's where it comes into making sense that is the answer between 30 and 40. It has to be. And in this one, it goes to 2, 4, 6, 8. It goes by 2. So this would be negative 32 degrees Celsius. And I'll be honest, the most common mistake on quizzes and tests on measurement and thermometers is forgetting the negative sign. And then this one is right at 0 degrees. Okay, so 0 degrees is the Celsius temperature. So those are examples, and that's how we practiced measurement today. On Monday, you're going to be doing a worksheet on measurement that if you get them all right, you don't have to test on measurement. So it might be worth it to practice this over the weekend, look at these again and see if you can maybe do some of your own practicing about measurement so that you wouldn't have to test. Wouldn't that be awesome if you could just test right out of measurement? So I want you to go ahead and think about it and practice and enjoy your weekend.